Okay, so your name and your country. Okujaku Ebie from Nigeria, welcome. Eligu Solomon from Nigeria, also welcome. Aminu from Nigeria. From Ghana, we have John from Ghana. Okay, we have a lot of people here. So welcome everybody. This is our first class for the training of offshore production DCS simulator and operations. Okay, so you guys are welcome. Okay, so currently we have 171 persons. So I think we are ready to go. Okay, so I think we can start now. Let's start now, right? So first of all, I want to appreciate you guys for the time that you guys have been waiting for this class. From January down to February, a lot of people have been in a group and they've been waiting for this training to start. And finally, we are starting today. So I want to appreciate you guys for the time. We are trying to, finish up with our DCS simulator. And, to the glory of God, DCS simulator is done and is working perfectly. So now we can confidently start up the training and ensure that you understand and get the knowledge you need to get at the end of this training. Okay. Now, I know a lot of people who just want to jump into the simulator and start doing startup, shutdown, open valve, close valve. Okay, but we have a lot of undergraduate students, and then we have a lot of graduate students also. So we have to take it step by step, right? So for today, we're going to start with the overview of the course, and also we'll now go to the fundamentals of our training. Okay, so we'll start gradually. We want to carry everybody along. We want all the undergraduate students to be able to understand what you're talking about. So we start from the beginning, and then we'll ramp up gradually to the top. So if you are experienced in this field, in operations, and you're here, I want you to just calm down and follow up with the class. And in fact, you are going to be a good resource to us during questions and answers, or let's say while I'm teaching, while I'm facilitating. Some students can be asking questions in the group, so you can just go there, respond to some of the questions you can actually respond to, so that because I will not be able to catch up with all the questions that we asked. So we have a lot of people here with experience, some of them 25 years of experience in the downstream sector, and most of them in the upstream sector. So we need you guys to help us with that, right? Okay. So for today, let's start with our overview. So okay, so confirm you can see my slide. Confirm you can see my screen.
Yeah, we can see your screen.
Okay, thank you very much. Thank you very much. All right. So basically, we'll be starting off with our overview of the course. Now, most of the things I'll be seeing here in the overview are things that I've already dropped in the group, right? Well, I want to emphasize on it so that we can put it at the back of our mind, and also we can work towards it while going forward in the training, right? So, first of all, my name is Epe Gunati. I'm a process engineer. I love simulation. I love Aspen ISIS. I love design. And, if you go to my LinkedIn profile, you'll be able to see a lot of things I do, right? And I decided to bring up this training because I know it's going to be good to a lot of people, right? And I've been in charge of training, new recruits in my company. I've been doing that. Okay, so I decided to come up with a good way of teaching people, right? Trying to bring up personnel up to speed. So, which is why I came up with the DCS simulator, right? So, and it has been proven that it's working perfectly. And I'm going to show you how that is going to help us. So, please, can we stop writing on the screen, please? Okay, so first of all, we all know that this training, the title of this training is Offshore Production DCS Simulator and Operations Training. Right now, if you look at the title, you find out that we are trying to bridge between two aspects: offshore production and operations training. And then we are trying to bridge that using our DCS simulator, right? Now, for the offshore production, we are going to understand, the value chain of the offshore system, right? From a reservoir down to the wellhead and up to the top side where we have separations and everything going on. And then we have the operations aspect where we carry out startup, shutdown, right? So we are using the DCS to bridge this gap, right? Now, we have a lot of training institutes, right? Most of them, what they do is they use PDF materials, they use images to try to make the student understand what they're teaching, right? Now, this simulator is going to ensure that you understand scenarios that are going on, like temperature increments, pressure increments, startup, putting on the pump, shutting down the valve and all the rest. So you're going to see the way everything is working on the plants, right? So this is not just like doing a theoretical training. This is me showing you how it's going to be working on the plant, right? The way a control room operator is going to sit down in the decks and then start, trying to troubleshoot, trying to ensure that the plant is stable. That is what you're going to do in this training going forward. Now, this training is structured in a way that everybody here is going to understand the practical understanding of offshore oil and gas. Now, we are using the control room oriented approach, right? Okay, we also know that the offshore facility is a very complex one. It is highly integrated, right? And then during operation, there are things you need to consider: the production, the safety, and the environmental factor. Now, these three things are, are going to work hand in hand simultaneously for you to have a smooth operation. So that is what you're going to be looking at. Now, the offshore is very limited in terms of space, right? If you look at the image by my left-hand side, you will find out that we have an FPSO. Now, you see the FPSO there. You see that everything is almost congested in one vessel, right? So the space there is limited. The space is limited. The manpower is going to be limited because before you go to this offshore, you go airborne. They are using helicopters to take you there. So it's not something that you can take 1,000 persons to the site. No, everything is limited. And this is why it is very important that everything is going to be automated. And when things are automated, it means the control room is what is doing almost all the work. We have field operators in the field that are going to be doing the field operations, but most of the things are automated, which is why the DCS operation is very, very crucial in the sense that, you stay in the DCS to monitor, to control, and also ensure that you safeguard the entire operations from the control room. Okay? So that is that. Now, this training is going to be focusing on offshore operations. Now, we are not going to be talking about design. Okay, so understand this. We are not talking about design. We are going to be using the HMI to show you how everything is going to work, and all the scenarios in case of there is any offset on the plant and all the rest. We are going to do that. So let's look at the purpose of this training, right? So the primary purpose of this training is to bridge the gap. I think I've said this earlier on. We try to bridge the gap between your theoretical knowledge and actual practical knowledge and what is happening in the field. So a lot of engineers, especially the undergraduates and the non-graduates, in school, we are taught about, the theoretical aspects. And you're told that separator is, separator does this, this does that, but the practical knowledge is actually not there. It's missing, okay? So which is why we are here to bridge that gap. So at the end of this this training, these are some of the things that you're going to go home with, right? You're going to understand how the overall configuration of the offshore production facility is. You're going to be able to identify major offshore production system. And then you're also going to be able to interpret the DCS. Now, whenever you see DCS, you can be able to know that, okay, this is what is going on the DCS. So you're going to understand that. And then you're going to follow up typical startup and shutdown, right? If you want to start up the offshore plants, what are the procedures you follow? You're going to understand that. You're also going to recognize alarm situations, okay? When there's an alarm on your screen, you're going to understand how to, why the alarm is there and how to rectify it. And also you're going to understand the role of interlocks and permissives. We're going to talk about interlocks and permissives, I think, in this day 2 of our training. So let's say next tomorrow we're going to do that, okay? So these things I just highlighted, they are very, very essential for all engineers and operators. So you're going to get that in this training. Now the scope of our training, okay, the offshore production system is a vast, topic, right? So me as a person, I can't do justice to everything. So we are just going to look at the parts that we can actually deliver to you guys for you to understand. So which is why we are going to cut streamline, because for offshore we have what we call subsea engineering, and subsea engineering is a course on its own, right? So it's a course that you can learn for almost 4 to 5 years, right? So we can't do that in just 10 days. So we're going to be cutting the topics into what we can do. So we're going to start from the reservoir down to the wellhead and then to export terminal, okay? So for the FPSO, we are going to start from reservoir, wellhead, to the top side and unloading to a tanker. So that is what we're doing. But for other fixed platforms, we are going to the export terminals. Okay, so basically the scope, I think I'll mention some of this. So, we have a production flow from wellhead through the manifold, and then to the top side where we have the separation and treatment of the fluid, which are your oil, your gas, and produced water. And then we have the gas handling, compression, and then conditioning to remove hydrogen sulfide. We have a produced water treatment and disposal or injection. So we're going to look at this. This is very, very important. Then we are going to also look at seawater treatment, right? So the FPSO or the offshore platform is situated in a sea where you can't actually be importing or let's say be bringing water from outside. So it means you have to treat the seawater and then you can use it for either domestic use or the injection to a well. Okay, so we're going to look at that. Then we have chemical injection, okay, to avoid corrosion and then a lot of other things. So we have that. Okay, so this training does not focus on process design. I think I mentioned this, line sizing, detailed mechanical design. So for mechanical guys that are here, we are not doing mechanical design in this training. For the process personnel, we are not doing process design, but we are doing process operation, okay? So we are not going to be doing equipment fabrication, and we are not going to be doing vendor-specific control systems. So we are not doing valve sizing and all the rest. So instead, we are emphasizing on operation, right? So operation is why we are here. Okay, so moving forward, so our audience, I think we don't need to talk much on this. We need an undergraduate student to be here. We need a graduate student, process engineers, instrumentation and control. Professionals that want to just know, have idea or understand what is going on here. And then we have process safety technicians and engineers. We also need a chemistry student are also needed because in offshore operations, we have the lab, okay? And the lab are the ones that actually take samples and then other samples and give you results. So we need them also to be here. So basic knowledge. All you need is to be an engineer, or let's say to study engineering, or chemistry, or industrial chemistry, or any of them, and also to just have a general idea of oil and gas and its terminology. Okay. Also understand fluid flow concepts, pressure, temperature, and level principles. So that's okay. If you have this, then it's okay. But if you don't have most of them, then it's not mandatory. Okay. So you can just follow up with the training. Okay, so I mentioned before that this training is going to be structured. We are not just going to jump into the DCS and start, the startup and shutdown. So it's structured. So we're going to start gradually, and then we're going to build up, to more advanced operational scenarios. And this training, I think, is divided into two sections. So the first section, we're just going to talk about, the general overview and operations, and then the second section is going to be the advanced operational aspect of it. So survey. Now for this survey details, I think earlier on January, I mentioned in the group that everybody should send their details, right? And I think I want why we need to send the details. And that is one of the reasons of these details is the time that I picked as 1 p.m. today, right? The reason I picked this time is because, we have a lot of countries. If I decide to pick around 4 p.m. or 5 p.m., some countries will be around 3 a.m. in the morning, okay, and it affects their attendance, right? So let's do something. I think let's just hold on. Let me bring up something. Yeah. Okay. So this is our survey details, right? Now we have about let's just say about 1,500 persons in the groups, right? In the two groups. Out of the 1,500 persons, we have about 700 people that sent their details. So which is what I use to actually carry out the analysis to do what I am about
Can
to
you
do
send
now.
this document to me?
Can you hear me?
Can you send this document?
Sorry, I didn't get that.
Can you send this document to me?
Okay, please, can you just type it on the chat? Let me see. I can't hear you clearly.
Yeah. Okay, 1 minute. I will type my email.
All right.
Okay, continue.
And please, if I'm too fast, okay, just let me know so I will slow down. All right. Yeah. I will send it. In the group. I'll send it. Yeah. Okay, so you can mute your audio now. Okay, so like I said, if I'm too fast, okay, you guys should just let me know so I can slow it down.
No.
Right? Oh, somebody said I should slow down.
No problem.
Okay, so I'm too fast, right?
No,
okay,
you are
so
good. Continue. You are good.
Okay. I will slow down a bit. All right. I just want us to finish before let's say 1 hour 30 minutes or 2 hours. So
okay, thank you.
All right. Okay. Now looking at our survey details, you notice we have a lot of undergraduate students. So let me just let me sort this out, and let's see. Okay, let's use country for example. Now for countries, we have okay, we have people from Algeria. So we have a lot of people from Algeria. We have from Angola. We have from
my
Cameroon.
number is 4717.
Okay, please just help me to mute your voice, okay?
Okay.
Thank you. Okay, we have from Ghana. We have a lot of people from Ghana. We have a lot of people from Indonesia. Yeah, we have a lot of people from India. I think the person I was talking is from India, right? So we have people from India. We have from Kazakhstan, Ivory Coast. We have from Iraq. We have from Mozambique. We have a lot of people from Nigeria, okay? A lot of people from Nigeria. And then, okay, we have from Nigeria. Okay, we have from Saudi Arabia. We have from Pakistan, Oman, Tunisia, United Arab Emirates, that is UAE. We have Tunisia. We have Uganda, and then we have UK. Venezuela is also here, okay? So, you see, we have a lot of people here, and you need to understand that this is like a resource to everybody, okay? Now, these people are working in different sectors. Most of them are working in refineries. Some of them are working in the gas plants. Some of them are working in ethanol plants, right? Now, it's a good resource for everybody, especially for the students. So you can reach out to any of them, and then they will still give you something. So let me sort out their sectors anyway. So we can see. Mr. Angulano, I see you're enjoying yourself. You're welcome. All right, so for the sector, okay, just hold on. Okay, for the sector, now let's look at the sector aspect now. Now I see we have a lot of chemical engineers here. We have a lot of computer engineering students here. We have people from the downstream sector. Now, most of them are DCS operators, right? But they are also here in this training. So you ask yourself, why is it that a DCS operator is attending this training? Now, the reason is simple. You're working in a refinery, doesn't mean that you can go straight and start working in the offshore, right? Because you need to understand, the process, the operations that is going on there. You need to understand the entire value chain, the system. So which is why they are here. Now, being here gives you that advantage, right? Whenever you see an advert online and you see offshore role, like a DCS operator or field operator, now as somebody working in a refinery, you can never apply. Even if you apply, you're wasting your time, right? That's because you don't have the certification, you don't have the knowledge, so you can't do that. Now, this training is going to help you do that. Now, you might have 50% of getting a job, but let's say 30% of getting a job. But at least you have a little percentage that when you apply, you can get a job. So we have E&P, exploration and production, they are here. We have people from the education sector, right? Some of them are lecturers, they are here. We have electrical engineers, they're also here, right? Electrical work is the same from downstream and upstream, but you need to know the equipment you're going to be, trying to connect, which is why understanding the process is very, very important. Understanding the equipment we have is also very important. Then we have fertilizer. So we have fertilizer people here. We have people from we have people from geology, okay, gas processing plants. And so, as you can see, we have people from a lot of industry gathered here. Now, some of them have 25 years of experience. Now, for you to have 25 years, it means you might either be a manager or you might either be operations manager or let's say a supervisor, right? So here you have it. You have people that can actually help you to get to somewhere. Even if you're not going to offshore, you can get to another sector, with these people you have in this group. Okay, and I will plead to everybody, if any of the participants here reach out to you, please just pay attention and try to take the person along. Okay, so let's go back to our slide so we can continue from there. I think we are here, right? Okay, we are done with this. We are here. Okay, so the next thing here, oh, sorry. Okay, so the next thing here is the rules to apply. Now, this is for the undergraduate student and the graduate students. You study chemical engineering doesn't mean that you are going to work as a chemical engineer. Okay, you need to be specific. You need to streamline yourself to a particular role. You are not going to work there as a chemical engineer. Nobody knows you as a chemical engineer, as a petroleum engineer. You are going there as. Please, can we mute our? Please mute your voice. Mute your voice, please. Is that
it's automatic. It's automatic.
Yeah, I just did that. You can just mute your voice, please. All right. So as I was saying, as a petroleum engineer, you can only be employed as a petroleum engineer if you're going as a trainee. Okay, that's when you can be employed as a petroleum engineer, as a trainee. Now, if you're going higher in life, you cannot identify yourself as a petroleum engineer anymore. You need to specify a particular role, right? So for people that have 0 to 3 years of experience, if you're just stepping out or going into the oil and gas, you will be employed as a trainee operator, right? So why am I saying this? If you are applying to any company, right, and you don't have experience, your experience is between 0 to 3 years, you don't go higher, right? You don't go for a control room operator, okay? You start from ground zero. You start from the trainee operator, right? So that is where you learn everything about the process, and then you start going up gradually. So you have trainee operator, you have a graduate engineer, you have junior technician, you have laboratory assistant. This for the chemistry student and the industrial chemistry, okay? Then we have the offshore cadets, and then the intern. And then if you have about 2 to 6 years of experience, now this is for somebody that is working in other sectors. Let's say you are working for a refinery, or let's say gas plant, for example, and you want to apply for offshore work, right? You have the idea about operation as a field operator in a refinery. Okay, so this is going to give you an advantage for you to apply as a field operator in offshore. So you can actually do that. You don't need to go back to trainee operator. You can do that if you want to anyway. But if you have the opportunity to apply as a field operator, then you can go ahead and do that, because you have the experience from 2 to 6 years. You can do that. So for operators, process operators, laboratory technician, maintenance technician, marine crew, and then utility operators, you can apply if you have 2 to 6 years. And then next is 5 to 10 years of experience. So if you have 5 to 10 years, that's when you can apply as a control room operator. Okay, so this is very important. Although you are learning how to become a control room operator, you don't just apply as a control room operator if you don't have any experience, right? So you have to build your knowledge, but having the certificate is going to give you backup, especially if you're applying to a small company that is just starting up, right? So you can just jump from field operator down to a control operator within a space of 1 to 2 years. That's allowed. But for a major oil and gas company, you don't jump from field operator down to control operator. You're going to go gradually, right? So if you have 5 to 10 years, you can attempt to apply for a control operator job, production chemists, mechanical engineers, and electrical or instrumentation, marine supervisors, cargo operator, and integrity engineers. So from 5 to 10 years, you can do that. And then also from 8 to 15 years, you can go for a supervisor for production and maintenance. You can go for supervisor for marine, and then HSC supervisor, laboratory supervisor, and utility supervisor. If you have 15 to 25 years, you can go for superintendent, okay? And then operations manager. Then if you have, higher, then you can go for what you call offshore installation manager, which is OIM, right? This is almost like executive level, okay? All right, now let's go over to assessments, okay? So assessment is very, 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 very important and is strongly encouraged. Okay, now this training, we want to expose you guys, want to expose everybody, to be able to build up your intellectual capacity in terms of you want people to know what you're doing, right? So I encourage people that you don't just go for a training and then at the end of the day, you just post your certificate online that I have just completed so training, right? For me, if I am an HR and I come to your, let's say your LinkedIn profile, and what I see is just you posting your certificates, I will not see anything to employ, right? It will not be employable to me. That's my take. Well, now if you show some level of, information and things that you've learned over the years, then somebody can actually, say, okay, this person might have idea on this. So let's give him a try and let's call him for interview. Okay. So I'll give us a brief statement on this later on. Now, participants are expected to follow posted materials. Now, post your LinkedIn platform for visibility. At the end of this training, you can get one post. You can even get more than one post, because what you're going to learn in this training, it can give you up to 5 to 10 posts. Or you can just do one post per class, okay? So you can do that and just watch out how people will start engaging your post. Now, I think some people are already posted, they are getting engagement already, and that is going to boost their confidence. Now, if they continue to do that before the end of this training, you say somebody will see them and say, okay, this person, let's do that. All right, so ask questions and then let it be related to operations and control philosophy. Also demonstrate understanding during interactive sections in the group. Now, the reason why I lock the group is I don't want too many questions to come up and disrupt. Some persons in the group, they don't like too many messages, right? So if they start seeing too many messages in the group, they will leave the group. So which is why I locked the group. Now I'm going to be opening the group intermittently to allow people to just discuss. But when it's time to discuss, try to make it more interactive. Okay. So certification now, right? For you to be certified, you need to participate. I think I mentioned that already. Now, also, you need to follow up the assessments. At the end of this training, we have about, let's say, 9 questions for you to answer, right? Now, for the questions, you can send it in form of the format of PDF or Microsoft Word. Send it to me on WhatsApp, right? I will record your assessments. Let me show you on that. Let me just take you through here now. Okay. Now this is for certification, right? Now you see we have the 1, we have the 2, we have the 3, we have assessment for all the days, right? Now you need to have about 90% assessment before you can be given a certificate. That's for that. Now these are people that have already made payments. So let's just go back to. Okay, so the next thing here is yeah, we have a little payment of $20. I think I've said this in the group already, so a lot of people already know about this. And ensure to follow up your visibility and industry readiness exercise. Ensure to do that. Now I'll tell you why this is important. Okay, 3 years ago, I started posting on LinkedIn. I think 4 years ago, but I started posting about my design experience 3 years ago. Now, while I was doing that, I was posting things about line sizing, equipment sizing, valve sizing and selection, pump data sheets and sizing and all the rest. Now, while I was doing that, somebody saw me on LinkedIn and then shouted me up. And he said, okay, that's my content or the knowledge I have is in line with what they are teaching in their institute. Okay, so that I should come as a representative, right? A representative of their company, and I was employed. Now, I will show you why this is important. Now, 3 years after then, this year, this January, I was appointed as the manager in charge of Africa, Eastern and Western Africa. Okay, now let's do this. Okay, so here is the company. This is a company, and this is what they do, right? They train on process plant design, advanced control, from operations to design. So if you want to switch from operations and go to design, you can come to this one. We have detail engineering, PSB sizing, Aspen ISIS, Aspen package, and we have other ones, right? So this is what they do, right? Now, because of what I've been posting online about these particular courses, they decided to, drag me in. There was no interview. I didn't submit my application anywhere, but I was called in to represent them. And, at the end of the day, maybe it's small cash they're coming in. All right. Now, this is when I was made. Yeah, this you can check them out on LinkedIn. Educational Institute for Equipment and Process Design, right? Now, if you come down, currently we are about to start process plant design course, right? Now, if you come down, you see, yeah, this is where I was appointed. This is 1 week ago, and I was appointed as the branch manager for Africa. Yeah, that is me. Now, like I said, I did not apply. They reached out to me, and then they said, okay, you are welcome to our company, start as a representative. Now, I am currently the branch manager. Now, you know what this means? This means I have the opportunity to now employ or bring in more persons. Let me just go to this other side and sorry, just hold on. Oh, what's this? Okay, so this is Africa now, right? So we have Burkina Faso, we have Benin, we have Cote d'Ivoire, we have Gambia, we have Ghana, we have Guinea, Liberia, Mali, Mauritania, we have Nigeria, Senegal, Sierra Leone, Togo, we have Burundi, we have Comoros, we have Djibouti, we have Eritrea, we have Ethiopia, Kenya, we have Tanzania, Uganda, Zambia. Now, all these countries are under my care. Now, imagine I can be able to go online, go on LinkedIn and begin selecting people that will represent all these companies, right? If you are doing this visibility and industrial readiness training, somebody will look at you and say, okay, let me take this person in. So this is the point I'm trying to make here. Okay, so let's go back. Sorry, your voice is not clear. Just type it on the comment section, please. Just type it there. I'll look at it. So let's continue. Okay, so for certificates, it is actually to acknowledge your successful participation. It is to also demonstrate your exposure to offshore production operations, and also to support the early career professionals, especially for the graduate students. Okay. All right. So next is I just added this on for you to see the standards involved in offshore operations, right? But most especially in terms of design. So you can just go online and look at this and maybe read to get more knowledge. So we have ISO 19900, that's General Offshore Structure Principle. We have ISO 19901, Environmental Loads. So you can go online and check all these, all these standards, okay? So I think the one that interests me most is ISO 19904, which is for floating offshore structures. Okay, so you can go there and learn, and also the engineering aspect of it. You can look at, they talk about the structural design philosophy, environmental loading, hydrodynamic analysis, stability and flotation. So if you want to get more knowledge, just download these codes for you to read more. Okay, so this is where we stop at module 1, right? So this is just overview of our training. Now, the next we are going to start the fundamentals, right? So any question, let me just go to our comment section.
Hello, good afternoon, engineer.
Yes, good afternoon, sir.
This is Emmanuel Akpabio, power generation specialist from Angola.
You are welcome, sir. Hi, you're welcome. I'm glad to have you here.
Okay. I just want to ask you just a naughty question.
Okay.
How will this skill really help in power plant operation? Because I'm instrumentation and control engineer,
Okay.
but happens to work in a power plant station. I'm from Nigeria, but it is the job that takes me to Angola. I'm in Luanda Island.
Oh, wow.
So
That's good.
how will this job, how is it related to power generation?
Power generation.
Yes.
Okay. For me, I think don't relate power generation to what you're learning here. Relate instrumentation to what you're learning here.
Okay.
Because I think that's your professional instrumentation, right?
Yes, instrumentation.
Exactly. So that is what you should relate to what is going on here. Okay. Now, instrumentation in all sectors, they're almost the same thing, right? In your power generation, I believe you have control valves. I believe you have transmitters. I believe you have temperature, pressure transmitters, and then we have also flow control valves, right?
Yes,
so,
yes.
Yes, exactly. So what you do as instrumentation is actually to connect all these devices down to your control panel, and then you send it to the control room. So is the same thing, right? For the offshore system, we have exactly the same thing. The only difference is that the equipment and the procedures are different. So you ask yourself this question: why are you here? Are you here because you just want to understand instrumentation, which you already know, or you are here because you want to, try to have a balance, so that in case you want to move to offshore, maybe in case somebody call you for offshore projects, you can actually say, okay, yes, I have idea, and you can move there, because everything is almost same. The only thing you need to understand is understand the concept of offshore operations. Sure, you get me?
Yes, yes.
Okay. All right. So if you want to discuss further, maybe later after the class, you can, chat me up. Although I'll be having a lot of, a lot of things to do after the class, but you chat me up and then we can discuss there. Performer can go ahead.
Good afternoon, sir.
Afternoon, sir.
Well done. My name is Sadiq Hosseini. I'm a process engineer.
Oh yeah, process engineer. Welcome.
I recently got employed in a gas processing facility.
Oh yeah, that's good.
So what type of skills and what are those key things you would advise me as this program is going on that I should note and key on just for future outlook? Thank you very much, sir.
Sorry, I don't get a question now. You want to work as a process engineer in a gas plant?
I currently got employed as a process engineer in a gas processing facility.
Okay.
It is supporting the operations. So my question to you is, what type of skills and what are those key outcomes I should aim in this training?
Okay. You're a process engineer, right? So I think what you should be doing or what you should be learning, or before you go there, I believe you already have some of the ideas about process engineering. But you're going there to troubleshoot. If there's any problem in terms of operations, your job is to troubleshoot. Your job is to optimize, right? You can use Aspen ISIS, you optimize, and then you inform the operations team that, okay, this is what you're going to do. You inform the maintenance team that, okay, we need to do this. We need to do this in order to have, stable operations. So your job is purely optimization, except maybe your process operation. Your process operation is to go into operation and start working with the DCS operator or start working with field operations, right? So I don't know the scope of the entire work you want to do in the company. I believe they give you an offer already. So with the offer, you can know the area you're working at.
It is mainly process operation supports and just surveillance.
Okay, so since you're supporting it, and I believe it's optimization. So most times, I think you can even take data from the control room. You go to the control room every day, you take their data, their readings, and then put them in Excel and try to look at the trends of how operations is going, and then you report. And also, when there is a problem on site, when maybe one equipment is not working well, what you do is you are the process personnel, so you have to think how or what is causing the problem to occur, and then you solve it. You tell mechanical team, okay, I think maybe a line is blocked, so area, so let's do this so that we can be able to solve the situations. Basically, that's it.
Yes, thank you.
You're welcome, sir. Okay, so I think we should move on to our next module. Okay, so somebody is asking, is there anyhow you can assist us to have DCS simulation software? I will tell you the simple truth, right? For those of us, the person I just spoken and said is working in a gas plant, right? Now, even if you're working as a field operator in a gas plant or in a refinery or any plant, it's most time very rare for you to even step your foot or move into the control room because it's highly restricted, right? Why this is important is because they don't want people to start exposing what they're doing, right? So it's very, very important. Now, simulators are very expensive. If I tell you how much I will sell my simulator, then you wonder why I'm doing this training for just $20, right? Because I can sell this simulator for as high as $25,000 or above, right? So if something I can sell for $25,000 and you feel I can just give it to you, just ask yourself, if you're in my shoe, will you give it to me, right? And I believe the answer will be no. Okay, so I don't know if this is clear, but to be honest, I can't give out the simulator to anybody.
Hello,
okay,
sir.
so yeah.
Okay, sir, please, I have a question.
Okay, go ahead, sir.
Okay, sir, please, I'm a HSC officer and also a supervisor. Please, I want to know, can you hear me over there?
Yeah, I can hear you. HSC, right?
Okay, yes, I want to know what will be the benefit of this training to me in an offshore or an onshore location?
Okay, thank you very much. Sorry, which sector are you working as HSC officer?
I'm working with Sepplans currently. I'm working in their gas
so that's
plants.
downstream,
Yes.
Right?
Yes, downstream.
The refinery or gas plants?
Yes.
Is it a refinery or a gas plant?
A gas plant, not refinery,
okay.
gas plant.
Okay, all right. So I think this is very simple, right? The reason you're here is to have an option of you leaving the gas plant and going to an offshore. Okay. Now, in the gas plant, what do? Your job is what? Health, safety, and environment, right? You try to balance these three important aspect of it. The health of the workers, the safety of the workers, the safety of workers and the safety of the equipment and everything, and also the environment itself. You are trying to protect the environment from the hazard that will be caused from operations of the plant, right? So that is what you're doing. And if you go to the offshore, you are doing exactly the same thing. Now, the only difference is that the the facility that you're working is different from the facility you're working in the gas plants.
Yes.
In offshore, you're working at somewhere that is very constrained, right? So it means your HSC ideas should fall into that system. You should know that, okay, this is where you're working. Now, if there's any issue, there's no way you can take workers, fly workers to somewhere else for treatment. They have to wait until we have a shopper to take them out. So which is why safety is very, very important in offshore. So all you need to do is you understand the equipment, you understand the process, and you can be able to talk about the safety of that process. You can't talk about the safety of anything if you don't know that thing.
Yes.
You understand? So which is why you need, okay, you know that in social place, in gas plants we have compressors, right? But if you go to offshore, we have pumps. Although we have compressors for the gases too, but then majorly they use pumps. So that's the difference. So if you know that, okay, we have pumps here, so how do you safeguard people, personnel from that pump, the operations of that pump? How do you give permits to work? We need to know the operations going on before you can give a permit to work.
Okay. So please, yes, sir, please, in offshore and onshore, the instrumentation design, are they differ from each other?
Instrumentation design?
Yes.
The
operations offshore and onshore.
The operations are different. Yes, instrumentation is the same, but then the programming part of it, they are different.
Okay.
You understand? Because you are using the same instruments. We are using control valves in onshore. We are using control valves in offshore. We are using the same type of communications, communicators to wire them together. So they are the same thing, just that the operations makes it different.
Okay.
All right. Thank you very much.
Thank you very much.
Let us move ahead. Okay. So everybody, just please let's mute our audio so that we can move ahead. Mechanical engineers, yeah, the same thing. Mechanical engineers, same thing. The same thing. Just understand the process. Understand what we have in offshore. That is it. For the undergraduate, is even good, right? Now, when I graduated, I never had opportunity for this kind of training, and because of that, I did not get into the oil and gas early enough, right? Now, in fact, at a point, I even left my engineering role, and then I was focusing on something else, right? I was doing something else instead of trying to focus on engineering, on oil and gas. So that is that. I was just I wanted to even finish my PhD before I can say I want to do another thing. But I have to merge all of them together. Okay, so it's very, very important for the undergraduate and then the graduate students for this training, because you are going to be focused. You are going to know what you are supposed to do, right? Immediately you're coming out of your schooling, you know that, okay, I can work as, so place, and this is what I can do. This is what I know. So it's very important. Okay, so let's just go ahead. Let's go ahead with our fundamentals. Okay, confirm you can see my screen.
Yeah,
sorry.
Yeah,
your screen is visible.
Yeah, we can see your screen, sir.
All right, thank you, sir. Thank you, sir.
Your screen is visible, sir.
Okay.
My hand is up. I don't know if you can take just one.
So somebody is asking SCADA versus DCS. Don't worry. We'll get to that. When we get to, I think day two, we'll talk about SCADA and DCS. So
with so much question, we will not be able to make progress in this training.
Exactly. So let's hold on.
Can we just pause the question for now? Or you can just
yes. And like I said, if there is any question in the comment,
we are just starting off.
Can you listen to me? Can you listen to me?
Yeah, I don't even know. I think I wanted to say that we are moving slow. Can we move faster?
Exactly.
Please?
Let's do that.
We have wasted almost, let me not say almost over an hour now asking questions, not within the framework of.
Okay, sir. Thank you very much for your listening. Now like I said before, some persons can be in the comment section to respond to those questions. Okay. I can't be answering all of them. Okay, so people can help me out to respond to some of these questions. So let's move ahead now. And please, let's stop writing on my screen. I don't like that. Okay, so for the module 2, we are talking about the fundamentals of offshore production, right? So here we are just going to look at the introduction of offshore. Now, I'll just play a little video for you. So as you can see, what we have here is an FPSO. Now you see the environment. You see the environment is, you cannot even see, the ending of it. We have water all around, right? And before you get to the FPSO or any platform, you use your chopper. You go through air, right? So you are not going through the sea, through boat or something else. You go through air. So this is how the offshore looks like. All right. So now the offshore oil and gas production actually refers to the extraction, processing, and export of crude. Okay, so we extract crude from beneath the earth surface, and then using equipment, we transport it to the top side of the platform, and then processing takes place, right? And it is exported. Now, some of them are exported to OPF, which is a onshore processing facility. And for vessels like the FPSO, we can load it out to a tanker because they can actually store crude oil in their hull. So with that, they can process for some days before they can push it out to a tanker via their unloading units. Okay. Now these operations, they carry out using surface facilities such as the fixed platform or the floating production units. So we have different types of offshore platforms. We have the fixed one, and then we have the what's it called? We have the floating ones. And also, if you hear of the word offshore, right? I want you to understand that we have different types of offshore. We also have offshore in what is it called? Green energy, right? Where we have a wind turbine on offshore, and then we have waves that actually powering the wind turbine. So we have offshore on that. We have a lot of angles for offshore, but then we are talking about offshore in oil and gas. Okay. Now, another thing you should also know is that if you are told that you are going to be working in offshore, there are different kinds of offshore, right? So don't expect that once you hear the word offshore, you're going to FPSO or you're going to a fixed platform. Sometimes they can take you to what you call a minimal platform. A minimal platform is one that just have one wellhead, and you can't even stay there. You just go there to monitor and then you go, right? So you need to know the kind of platform that you're going to be working on. But we'll look at all that very soon, okay? So unlike the onshore production, the offshore operations must be executed in a highly constrained environment. I think I've said some things about this because we have limited space, and then we have safety, we have accessibility, and then we have a lot of critical, things to consider during operations. So offshore facilities, they are typically located far from shore, just like the video you watched, okay, making logistics, maintenance, and emergency response more challenging. So if there's any issue on offshore platform, maintenance and logistics are very, very difficult. So which is why they try as much as possible to ensure that everything works smoothly without any issue, right? And most of the things are automated, okay, to avoid accidents and to avoid human errors, okay? So as a result, offshore production systems, they are designed for high reliable automation and continuous operation. You don't need to shut down. If you are shutting down, it's for a major maintenance, just like the Bonga shutdown that is going on currently. The Bonga offshore is currently shut down and they are doing maintenance. Okay, so it's something that you do after some years, not like every 1 week you shut down and start up. No, that's not good. Okay, so the role of operations and control systems in offshore is therefore very, very crucial. Now, every process action from opening a well to exporting stabilized crude must be carefully controlled to ensure safety, environment, compliance, and production efficiency. So let's look at the value chain now. The value chain in offshore is very simple. We are starting from reservoir, and then the well production. Okay, so because we have a lot of undergraduates here, we are going to go down to even talking about the reservoir, right? In this our course of study. So we'll go down. I think that will be in day 3 of our training. So we'll do that. Now the flow of fluids from subsea down to surface facility, separation of oil and gas, treatment and conditioning of each of the phase, and then compression, injection, and export. So this is the value chain. It starts from reservoir and it ends at the export. Okay. Now each of the stage is interconnected. If there is any problem at the export, if there's any problem at the export terminal, then especially for fixed platforms where you are not storing the crude. Now, if there's any problem at the export pipeline, it means you have to shut down. So everything is interconnected. If there is any problem at the gas compression station, we have gas coming in, so you have to compress it and send it out. So if you cannot send out gas, it means you have to shut down because the pressure of your lines, everything is going to go up, and then before you know it's kaboom. So everything is interconnected. Now, a disturbance at any point in the chain can affect the entire operations. Okay, so understanding the integration is fundamental to offshore production and DCS control. All right, so like I said, we have different types. So here is where we talk about the different types of offshore. Okay, now during interview, if you want to go and work on offshore during interview, the person interviewing you can actually wants to test your brain to know if you really understand the offshore, right? Now, let's say somebody asks you, okay, you are going to be working in a fixed platform, and then you are going to be storing the crude for, let's say, 1 week. Like every 1 week, you send out the crude. What will be your response? It's a fixed platform, meaning you can't store crude. You have to export it out. But the person is not telling you that, okay, that we are storing crude for 1 week or 2 weeks before it sends out, right? So that's just testing you to know if you actually know if a fixed platform doesn't have a storage system, okay? So these are the things you need to know. So that is why you need to know the various types of offshore. So let's start with the number 1. Okay, so number 1 is our fixed offshore platforms. As you can see the image, this is a fixed offshore platforms. Now we have various types, so we'll talk about the various types of fixed platform also. So for fixed platforms now these platforms, they are rigid structures, right? You can see, look at the image here, you see that they have rigid structures that are used to, to support the top side, and then these structures goes all the way down to the seabed, and then they are anchored. They have anchors that are used to anchor on the ground. Okay, so they are most commonly used in shallow to moderate water depths. Now, since they are going to be anchored on the floor, it means you can't take it to somewhere that is too deep, right? So somewhere around 100 to about 400 meters, you can have something like this. But if you have about 1,000 meters deep, you can't be using metal plates to actually support your platform, right? So that is where you now know that, okay, let's take, for example, somebody asks you, you're going to be working in a fixed platform, but the water depth is about 1,500 meters. What would you say? Now, you will know that it's not possible. It's not possible for a fixed platform to be situated in a water depth of 1,500. It has to be something else. It has to be either FPSO or maybe a Spar unit. Okay, so just understand that for fixed platforms, from 100, 300 to about 400 meters, that's where you find a fixed platform, depending on the structural design. So we'll look at the structural design later. Okay. Now, these platforms, they are supported by steel jackets. So those legs we're seeing, they are called steel jackets. And then we have gravity-based foundations. Okay, so we're going to look at the GBS later. For now, let's look at the steel jackets. Okay, now these are used to make the platform stable under wave, wind, and current load. Okay, now since it's supported, it means when there is wind, you can't actually push it. Okay, because it's very rigid, you can't push it. When there is a wave, the wave cannot actually push it too, except maybe a very high wave can actually collapse it or push it aside. Okay, but for some kind of wind, you can support it. Okay, now the fixed platforms, they're often accommodated drilling. Now for fixed platform, you can carry out drilling. Okay, so while you're producing on let's say 1 to about 10 wells. They can be drilling other wells by using directional drilling. Okay, so you can see the drilling rig mounted on the fixed platform while production is also going on. All right, so production is going on. We have utilities like your boilers and other utilities, and then we have the living quarters also. Okay, they are on a single structure or multiple interconnected structures. So we are going to look at that also later on. Now, fixed platforms are designed to withstand wave. So I talked about this. Now they can stay for about 25 to 40 years, okay, before it can be decommissioned, right? And then also fixed platforms, they accommodate drilling, production, utilities, and living quarters. I've talked about this also. So let's go over to the next one. Now, examples of fixed platforms. You can check this out later on. We have the Prinos Delta and Lambda platforms. We have the Focado and Ocam platforms. We have the Ecofix field platforms in North Sea. And then we have the Bullwinkle platform, sorry. Okay, so GBS now. GBS stands for gravity-based structure. Now, you can see the structure here. It is made from concrete cements, right? So these are the structures. Now, this is when you have, somewhere that has a lot of environmental disturbance, especially like maybe ice blocks, snow, okay? So we use the GBS for that kind of location. And also GBS can also store crude, so which is why GBS is also used. Now, GBS, they are special category of fixed platform that they rest on the seabed. So they rest because of the load. You can't actually make it to float. So they have to rest on the seabed, and they are mostly used at a very shallow region, right? Maybe the water depth of about, let's say 30 to about 100 or 200. That's why they use GBS. Okay. So the operational characteristics of GBS, they are extremely stable, very low in motion, okay, because it's very heavy, so nothing can push it. And then they integrate storage capacity. So the GBS, you see the hull here, they can actually store crude on it, then later discharge to either a tanker or through export pipeline. So example, we have the Sturgeon platform, and then we have the Ibenia platform. Now this Ibenia is one of the largest oil platforms. You can check it out, Ibenia platforms. Okay, it's in Canada. Now this is when they were towing the entire platform down to the location. You can see the image, and the water depth here is 80 meters. Okay, just 80 meters. Then you can see the structure. This is the structure you're seeing here is where the crude is being stored, and then these angles they are used to actually break ice. Okay, they are called ice crackers. Okay, so we are done with that. The next is our compliant towers. Now, compliant towers are also fixed platforms. Okay, let's look at what the compliant tower is. Okay, so these are narrow, flexible offshore oil and gas platforms designed to withstand environmental forces by swaying slightly rather than resisting them rigidly. Okay, so for the fixed platforms, they are positioned in a way that you can't move it. Now, for these compliant towers, they are also sent down to the seabed, and then they're anchored, but they are more slimmer, and then they can sway, right? So there's a wave, they can just sway and then balance up. So that is the essence of this. So they are typically used in water depths ranging from 450 to 900 meters. Okay, so instead of using a fixed bed, fixed platforms, they use compliant towers. If you see a water depth of 450 to 900 meters. Okay. Example of this is the Petroleum platform. It's in Mexico and is handled by Chevron. And then we have the Bad Pate platform. We have the Benguela Belize platform. This is in Angola. Okay, now for the Petroleums, the water depth is 535 meters. For the Balpate, the water depth is 503 meters, while for the Belize is about 512 meters. So even if somebody asks you, okay, where you're going to work, the water depth is so let's say about 800. You know that, okay, what you have there is a compliant tower. It's either a compliant tower or maybe FPSO or some other ones, but not a fixed platform. Hope you understand this concept. Okay, so the next one is the minimal facility, okay, and wellhead. So if you are from Nigeria and then you stay in the, let's say, the Niger Delta part of Nigeria, you know, why if you are going through a boat, you find out that you see some small platforms with a wellhead, a dry wellhead on it, right? Those small platforms, they are called wellhead platforms. Now, they are not platforms that people can go and stay, or production cannot go on that kind of platforms, okay? So for that platform, it's just to extract the crude and then you send it through pipeline to OPF, okay? Or you can also send it to maybe FPSO if there's any other facility close to it. So that is what we call wellhead platform or minimal facility. Okay, so it's very important that we know this difference between all these kind of platforms. So let's look at the interpretation. So they are offshore installations designed primarily to support well drilling. Okay, so during drilling, they can use this kind of platforms, completion and initial production control. Okay, so they use it for initial production before you can bring in a bigger platform, like maybe the FPSO or something else. Now, their main function is to host the wellheads and the Christmas trees while producing fluids are routed to nearby host facility for full processing. Now, these platforms are typically used in shallow to moderate water depths and are especially common in satellite fields development, marginal or small reserves, early production schemes, brownfield expansion where a central processing platform already exists. Okay, so unlike the full production platforms, separation, compression, dehydration, all these cannot go on. Instead, multi-phase fluids are exported via flow line to a central processing facility. Okay, the fixed production platforms, FPSO. Okay, so let's go. We are done with fixed platforms now. So don't forget, we mentioned for fixed platform, we have fixed platform with steel structure. We have the one with GBS. We have compliant towers, and then we have the wellhead and minimal platforms. So we are done with fixed platform. Now we need to go over to floating production system. Okay, now these are systems that can actually float, right? They are the support. They are not anchored on the bed, right, on the seabed. Instead, they use mooring lines to actually anchor them. Okay, but they're actually floating. So as you can see, these images show you some types of floating production system, but we'll look at them one after the other. So for the floating production system, they are used in deep water and ultra deep water environments. So if you hear deep water, we are talking about water depth from about, let's say, 500 down to about 1,500 meters. Then if you hear ultra deep water, you're talking about a water depth of 1,500 and above. That's ultra deep, very deep, right? Okay, so they are typically not economical. Okay, now these facilities, they are designed to float on the surface and they are anchored by mooring in position. Common types of floating production systems, they are the FPSO, they are the semi-submersible production platforms, the TPL, which are the tension leg platforms, and then we have the Spar. So we are going to look at each of these again, one after the other, to explain why they are kept, why they are going to be used, and where they are used. So look at them one after the other. So for FPSO, they are particularly popular. They are very popular because they combine both processing, production, storage, and then the exports. And then floating facilities are widely used for deep water, remote location, and then field requiring flexibility or redeployment. So here we have pictures of FPSO. So we're going to start with FPSO first, and then we have the different parts in the FPSO. From the left, we have the unloading, we have the living quarters, we have the lifeboats, we have the power generation units, we have water injection, we have crude separation, we have gas compression, we have the turret. So we're going to talk about turrets. We have the flare, and then okay, so we have the helipad at the top. Okay, so that is that. Now, also we have another one called the floating liquefied natural gas. So this is for gas. So if you are producing a gas, only gas well, then we have these floating units there, okay? Then we have other ones called the floating storage unit. So that's for just floating. This smaller vessel by the side is a floating storage unit. And then we have what we call the FSRU, floating storage regasification units, okay? So that unit is used to regasify the compressed gas, okay? So for gas to be sent to export terminal, most likely they are going to be compressed to about minus 100 and let's say 162, 165 degrees Celsius, right? To turn it to liquid for you to be able to store it in the FSU, right? But what if you want to export? So you want to export through pipeline, you need to regasify the compressed gas to your normal gas at room temperature. Okay, so that's where we have the FSRU. So floating production, storage, and offloading units. That is FPSO, okay? If you're hearing this for the first time, understand that FPSO means floating production, so that's for F. The S stands for storage, and the O stands for offloading units. And you can see the various parts, risers, we'll go through that. We have the mooring lines, we have the mooring system, the turret is also there. We have the storage tank, we have the top side. The top side is actually on everything on top. The FPSO is called the top side. Then we have the offloading facility. So FPSO are ship floating facility that are integrated. Production, processing, crude storage, offloading to shuttle tanker. These are all integrated on what we call the FPSO. Now, FPSO are particularly attractive because they eliminate the need for us to use export pipelines, making them ideal for remote or marginal fields. Water depth for FPSO is about 100 to 2,900. So any place between 100 to 2,900 meters, the FPSO can be used. Okay. So the key operational characteristics of FPSO include large onboarding crude storage tanks, periodic offloading operations, the turrets or spread mooring systems. So let me just talk about this turret a little bit. So the turret now, has anybody seen an excavator working? Excavator, or let's say swan buggy. Now, excavator is that machine that is used to dig out the earth surface, right? Now, if you look at the excavator working, you notice that excavator can rotate 360 degrees, and then the cabin and then the boom, they will be working while you're rotating, okay? So it means the rotation is not interrupting the fluid, the hydraulic fluid that is passing through down to the boom for it to actually work. Now, this is the principle of what you have the turret for, okay? So for FPSO, they call it turret, but for the excavator, they call it turntable, okay? They call it the turntable. So the turntable is where it rotates, allow you to rotate, and then operator carry out his digging operation and all the rest. Now for FPSO, the turret actually enables the FPSO to rotate due to winds, okay? Because we have a lot of winds in offshore, so the wind can push the FPSO to rotate. Now while it's rotating, it's not going to affect the risers or the pipes that are coming up from the sea level, okay? And also the anchor, the moorings that are there, it's not going to affect it. But it's just going to rotate. So it's going to allow it to rotate without affecting operations. Okay, so that is what the turret is meant for. I think we're going to still talk about this turret. We look at the turret critically in I think before also. So for now, just understand that the turret is we have turret and we have the spread mooring. So the spread mooring is if you look at some FPSO, we have the mooring system anchored at different locations. Okay, they don't have the turrets, which is a single place where everything is anchored. For the spread mooring, they have different locations where the mooring lines are tied to. Now, for the spread one, it will not allow the FPSO to actually rotate 360 degrees. No, you cannot do that. It will just maybe allow it to move a bit. You understand? Because there is a mooring line here, there's a mooring line here. So it will just allow it to just move slightly and then it will stop. So that is that. Now we have extensive topside processing facility. Then we have the absence of export pipeline. Okay, so let's look at examples of FPSO. Now in Nigeria, we have one of the biggest, or let's say the biggest. I think Bonga can process about 225 million, okay, 225,000 barrels per day. Okay, so that is what it can process per day. All right, so it's like one of the biggest FPSO in Nigeria, and it's located at OML 118. OML 118. Now, there's a reason I mentioned this OML 118. Okay, so later on in this course, we're going to look at all these terminologies. Okay, so we have the Agbami FPSO platform, OML 127 and 128. We have the Girasol FPSO in Angola, Block 17. We have the EHA FPSO. We have that is in OML 133. We have the Akbo FPSO. We have the Abo FPSO. And I think there is one that is going to these states in Calabar also. One new one from I think I've forgotten the name, but there is one new one there. So these are different types of FPSO. So you can just Google it out, look at their production capacity, get more idea about the FPSO, follow up with your company and see if there's any vacancy or anything. If you're in Ghana, do the same thing. Go to go online and check for FPSOs in Ghana. Follow up with their operators, because most of them are operated by Chevron, most of them are operated by Shell. So just look at the operators and then look at opportunities. All right. So yeah, you can see the mooring system. So this is the mooring system. Now everything is anchored at the mooring system. Okay. Now all the risers, including the umbilical line, is coming through the mooring system. Okay. The next is we have the semi-submersible production platform. Okay, so why is it called semi-submersible? Semi means some part of it is submerged inside the water, right? Now the rest they are visible, but the whole part is submerged. Okay, so that's semi-submersible. Now what is making it to float is actually what you call the pontoon. That's what they call the pontoon. Now you might ask yourself, why is it that Swambugi is floating? Because Swambugi, they are used to use it to operate in areas that are very swampy, in riverine areas, so they can float, and they are floating because of what they call the pontoon. Okay, now the same principle applies to semi-submersible production platforms. Just imagine a very heavy platform like that is floating. Okay, it's because of the pontoon, and it has been designed to be able to carry the weight of everything at the top side. Okay, so let's look at that. Now, the semi-submersible platform consists of floating pontoons and vertical columns, okay, designed to minimize motion by keeping most of the structure submerged below wave action. Now, they are commonly used for deep water production of 1,000 to about 1,500. Now, you see these values are very, very important, okay? Because if you are asked in an interview, which kind of platform do you think will function in a water depth of about 1,000 to 1,500? The options you have now is FPSO, because I said FPSO is from 100 to 2,900. So FPSO and semi-submersible, right? Because fixed platform cannot work here. So you need to know this. These values I'm talking about for the water depth is very, very important, right? So we have ultra deep water production. I told you that ultra deep is anything greater than 1,500. So they can even be used at something about, let's say, 2,000 meters, 1,800, 1,900 to 2,000 meters. So that's where semi-submersible can actually work. And then they combine both drilling and production. Okay, so they can actually drill on this type of platform. Okay. Now, next is the operational consideration. Okay, we have the ballast control system. We have the station keeping and mooring integrity. Then we have the wave motion aware process control. Okay, so the other way that this kind of semi-submersible platform to actually be in one location is we still have what we call the mooring system. Okay, so they are being moved by mooring lines to this, and they are anchored on the seabed. Okay, so which is why they are located in one region. Okay, if not, anything that is floating, the wave can actually push it aside. But because of the mooring system, they are kept in place. So example is the Thunder Horse. Please always check out, after the class, you can just go online and check out these examples I'm giving you. And you have the most, Kizomba A is in Angola. So we have these two as examples for semi-submersible. So the next one is tension leg platform. So from the name tension leg, it means it's something that is tensioned. Okay, for the semi-submersible, it is not tension. We have mooring system, but they are slacked. Okay, they are not tension, just slack, something slack that will just enable it to just stay at one location. But for the tension leg, they are tensioned down to the seabed using what we call the tendons. Okay,
Engineer, I
please.
just wanted to add up. Sorry, good afternoon. I just
Okay,
wanted
please, can we
to
just
head
keep
up.
this at the end of? Can we keep this at the end of the training then answer question, because we are at 1 hour 28 minutes already. Please, just keep it at the end of the training. Thank you. Or you can just write it down so I remember. Okay, thank you very much. So TPL. Okay, so for the TPL, like I said, the attention, they almost work as your floating system, because they are floating, but then the attention to stay at one location. Okay, so they work at they can be used at areas that are very shallow, up to 400 meters, and also for deep water from 1,000 meters to 1,500 meters. And they most likely have dry wells. Now, dry tree wells are actually wells that can be mounted on top of the platform at the top side. Okay, so that's dry tree well, because they are not wet. They are not inside the subsea. They are at the top. Okay, now because they are used to reduce vertical movement, TPL allow for direct access to wellheads on a platform, and they are similar to a fixed platform. This simplifies well control operations, but introduce unique structural and operational consideration. So example of TPL is the Auger TPL in Mexico. We have the Hedron TPL in North Sea. Then we have the Spar. So the Spar is, I think the Spar is going to be the final example for the floating systems. So the Spar, as you can see, the Spar has just one what's it called? Hull system that is submerged inside the water, and then the other part is at the surface, holding the platform together. So the water depth for Spar is above 1,500. So the Spar is actually used for ultra deep water system. Then we have a very deep environment. That's where you use the Spar. So you can be around 2,800, 3,000 meters. So that's where we have a Spar. So in case somebody asks you that, okay, we have a platform, and then the water depth is about 2,000 meters, about 3,000 meters, you know that it's going to be a Spar. Okay, so the operational features of the Spar is that it is excellent motion performance. It has complex mooring systems and is high installation and construction costs. Okay, it's very, very cost intensive. So example for this is the Perdido Spar. This is also one of the biggest platforms in the world. So check out the Perdido platform, and then we have the Asta handstand platform in Norway. Oh. Okay, so let's look at the subsea production system. Okay, so in your engineering classes, there is a course titled Surface and Subsurface Production, right? So surface is the top, the subsurface is anything below the ground. Now for offshore, we have another layer called the subsea. So the subsea is what differentiates between offshore and onshore. For onshore, there is nothing like subsea systems. But for offshore, we have the subsea. So this is different between offshore and onshore. Every other thing is almost the same, except the space and the type of platform that is used. Okay. Now, we are going to look at the subsea system. And like I said, subsea is a very broad topic, right? We have a lot of equipment and we have a lot of engineering going on currently. So we can't talk about everything about the subsea, but we'll look at it, step by step. We look from the wellhead, we look at it down to the platform, and we look at all the equipments that are needed on the subsea. So for this module 2, we are just going to introduce the subsea systems. Okay, so if you look at the image by my side, you see the flow jumpers, you see the pumping station, you see a manifold. So what you're seeing here is a manifold, and then you have different wells. You have about 1, 2, 3, 4, 5, 6, 7, about 7 wells surrounding one manifold. Okay, so the manifold, just like your manifold in the downstream sector, where we have just a pipe, and then we have connectors connecting to that manifold, and then sent to maybe an equipment or something. This is what manifold in subsea looks like. But we are still going to look at this later on. Okay, so because subsea equipments they are inaccessible during normal operation, these systems, they rely heavily on automation. Okay, so everything at the subsea rely on automation. Because now the only way you can go down to the seabed to carry out any maintenance is by going through what they call a ROV, remote operated vehicles. Okay, so that's the only thing you can go with. Divers cannot really go in deep down to go and do any maintenance work. Okay, so everything has to be automated, right? Now, operators typically control subsea systems entirely from the control room. So everything is done from the control room, making DCS reliability specifically or especially important, very, very important. So subsea systems, we don't need to talk about the types, but let's look at Aegina subsea systems, and then we have BC 10 in Brazil. Now, this is just to inform you that we can integrate various offshore platforms together. Okay, so we can have one platform here, a fixed platform. We have another fixed platform here. We have another fixed platform there, and then we link them together. So as you can see the image here, you see that we have different platforms that are linked together, and then we have the separators on this one. We have living quarters here. We have the processing going on different locations. Okay, so we can link them, all of them. Now, in some instances, you can have one platform that is just focused on utilities, right? Focus on generating utilities and then sending your utilities down to the other platforms. And then you can have just one platform for only processing. Then you have another one for only draining. And then all of them, they are linked together. Okay, so that's integrating various offshore systems. So modern offshore production often combines multiple facilities types into a single integrated system. For example, subsea wells tied back to an FPSO. So an FPSO can also be tied to a subsea well from another platform. And then we have fixed platforms connected to subsea clusters. Then we have multiple FPSO. So we have a lot of FPSO that we are sharing one export infrastructure. Okay, so that is integration. Now, these integrated systems, they increase operational complexity and they require advanced control strategies, clear operating philosophies, and well-designed HMIs to ensure safe and efficient operation. So understanding the interactions between these different facility types is very, very, very crucial, right? Now, let's look at the impact of facility type on operations. So let's say you are an operator, right? You know that understanding these different facility types is very, very important, because for fixed platforms, the way they design their HMI might be different from the way they design the one for FPSO. Why? Because FPSO have loading and unloading units, right? They have loading and unloading units. Now, for the fixed platform, there's no loading and unloading units, meaning the HMI, the design, is going to incorporate the loading units into the DCS system, while for fixed platform, there's no loading units, right? So you need to understand that, okay, if you have something like a well platform, you know that there is no DCS on that well platform, except that well is now tied to a DCS on OPF. onshore processing facility, right? Or maybe it's tied down to another platform. Okay, so we need to understand this as operating or operators in the field. Now, the choice of offshore facility type directly affects process layouts and equipment arrangements. They affect control philosophy and alarm strategies. So different platforms can integrate different type of alarm strategies and control philosophies. The emergency shutdown and safety systems can also differ a little bit. They are going to be almost the same, but a little bit. Now, it also depends on the company that is also designing it. Let's say ABB, different companies that integrate all these things together. Then we have operator load and situational awareness. Okay, because the awareness you have on FPSO might be different from what you have on a fixed platform or GBS. Okay, so a simplified offshore production process generally follows the sequence. Hydrocarbons flow from the reservoir through wells, fluids are routed to manifolds, and then flow line. All this are happening at the subsea level. Okay, the multi-phase fluid enters separation units. Now this is at the top side. Oil and gas water are separated and treated at the top side. Oil is stabilized at first, second, and third separators, and then they are sent to export terminals. Now, before they send to export terminals, a lot of treatments are going to go into place, okay? Because of environmental or let's say regulations, they have to reduce the hydrogen sulfide level to let's say about 5 ppm, or let's say maximum 50 ppm. So you have to treat it. And for the gases, you have to compress the gas. You have to also treat the gas. Okay, so a lot of things are going to take place before we get to export terminals. Now the gas is compressed for export, injection, or fuel. Now our gas is also used for injection. So I think we're going to look into this also. Then the produced water is treated and disposed or injected. So for all the platforms, this process will take place, okay? So their process flow forms the backbone of offshore production and will be visited throughout the course using the HMI simulation. Okay, so major offshore production systems overview. Okay, so I think we mentioned this already. Wellhead to manifold, production separation, crude treatment, dehydration, gas handling. I think we mentioned all of this. So the next, let's look at types of oil and gas licenses and lease. Now, why are we going to talk about license? We are going to be operators, right? We are not management staffs. So we are not going to be talking about signing contracts and all the rest. But why, as operators, we need to understand the types of licenses, right? Let me give an example. Now, let's say you are carrying out an interview, and then the person interviewing asks you, okay, where we are situating our platform is a OML 112. OML 112. Now, immediately they mention OML 112. What should come to your mind is that this company, they have the license to drill, they have the license to produce, they have the license to export, to process and export, right? Now, there's a license they will give to a company. They cannot produce, they can only drill. In fact, there is a license they can give you. All you can do is just to explore. You just explore, you cannot even drill, right? So having this knowledge will make you understand that, okay, I want to work in this company, and this company, they are doing so thing. OML, so thing, they are actually operating, they are drilling, and then they are exporting, right? So which is why we need to understand this aspect. So let's look at some of the types of lease and licenses that are needed. Okay, so the first one is OML. Now, when I was mentioning the types of offshore, where we have Bunga, we have Agbami, we have a lot of them, there are OML beside this. Now, the reason I did that is because I know I will come to this, and then we'll talk about why we need this. So OML stands for Oil Mining Lease. Okay, so for the oil mining lease, what exactly is going on for the OML? Now, OML is a crucial government license. So the government gives the company this license, and this license grants the company the exclusive rights to explore. They explore, prospect, and then they produce oil and gas with a specific area. They call it acreage. So there is a map. Okay, you cannot encroach or you cannot exceed that map that is given to you. Okay, so every company has a particular map that it can only work in that region. You cannot just drive your FPSO to any region and then you start drilling or exploring. No, they are going to give you a license, and that license is what you use to carry out your activity in that particular region. And they use coordinates to map out this region for you. And this OML lasts for 20 years. 20 years. So after 20 years, you will need to go for appraisal and also see if you can get another license again. Okay. Now this comes after OPL. So we're going to look at OPL. OPL is the oil prospecting license. So we'll look at OPL later on. Okay. So the purpose of this OML is for production, development of crude oil and associated gas. Now the area is typically offshore or onshore area. So if you hear OML, it doesn't mean it's just offshore. Even onshore platforms, they are within these licenses. Okay, so OML 111, OML 123, OML 133, and all the rest. Then the operators are going to have the full rights to drill, produce, and market the crude oil within that lease area. Okay, so duration, like I said, is 20 years, and you can renew it after the 20 years. So example for Bonga, you can see from the map here, you see Bonga here. Bonga is also having a location that it has to work. Then we have the Agbami. So Bonga is OML 118. The Agbami is OML 127 and 128. So OPL stands for Oil Prospecting Lease. Okay. Now this is also a government issued right, allowing a company to search, explore, and potentially extract. Potentially. Okay. So you cannot extract, you can only search and explore. Now after you search and explore, you need to go and get the OML. You need to meet the government and say, okay, I've seen oil, I want to drill, I want to what produce. Okay, so they will not convert the OPL to OML for you. All right. So I'm not talking about this in terms of management. I'm talking about this in terms of operator level, because you need to understand that, okay, if I see anywhere they say OPL, it means, oh, this place, they are not going to be drilling. Okay, so I'm going for just exploration. So that is E&P. All right. Okay, so let's move further. So the purpose is simply exploration only with no production rights. Typically, it's given for just 5 years. So after 5 years, you have to renew it. Oil is discovered. When oil is discovered, you have to convert the OPL to OML, all right, for you to be able to start drilling and production. So examples and stuff. So let's go further. So the next one is the PML. So PML is almost like your OML, right? But it's a new version of it. So PML is a term petroleum mining lease, and it's also called exploration blocks. So PML primarily stands for petroleum mining lease. Is a crucial license granting rights to extract, discover oil and gas. Replace the older term oil mining lease, which is the OML. Now OML is still functioning, right? You can still see people saying OML this. It's still there, but we have a new version of it called the PML. So if you hear PML, it's the same thing as OML. Okay, so let's not confuse with this. So this is also for 20 years. And a block is also the same thing. It's a geographically defined area of the seabed or offshore territory that the government grants an oil and gas company for exploration, development, and production. So if you hear block 17, it's the same thing as OML or PML, okay? And it is essentially the legal footprint within which a company can operate. So blocks are defined by precise coordinates, latitude and longitude. They can vary in size. Shallow water blocks are smaller, while deep water blocks are usually very large, okay, to cover multiple reservoirs, okay, because it is not easy for you to move your vessels down to that deep water to do exploration and you just explore just small region. So they have to give you a large region so that you can explore a lot for you to be able to see different ways for you to convert it to start producing anyway. So each block has a license type associated with it, such as OPL and OML. So I've talked about all this. Okay, so PPL is almost like your OPL, all right? So the same thing like your OPL. So no need for that. No need to explain this any longer. It's the same thing anyway. Okay, so the role of operations and control room. So this is just like a summary, right? We are not really talking about the entire role of operations and the control room because we are going to do that later on. But the offshore operations, you have to know that the control room is where operators monitor process conditions, temperature, pressure, flows. They monitor it. What they do is they look at it. Let's look at this image here. So you see we have temperatures, we have pressure here, we have LC is a level transmitter. So what you do is you look at the levels, you observe the trend of the levels, you open graphs and then you check, you confirm if the level is above or below. You see, you look at everything and ensure that everything is stable. So that is what you do at the control room. Okay, so we keep operators responsible. Okay, key operator responsibilities include maintaining stable production, responding to alarms and trips, coordinating startup and shutdown activities, ensuring safety and environmental compliance. And then the DCS provides operators with real-time visibility of the plants. So from the DCS, you can see everything about the plants, right? It's like the heartbeats of the plants. Okay, so you see the DCS just like you are seeing the heart of the plants. Because if you go to the fields, you cannot see what the DCS operator is seeing. You can only see the skeleton of what is going on. But the DCS is seeing the internals of what is going on. Temperature rise inside the towers, they are seeing it. Inside the separators, what is going on? The temperature or the pressure. If it's increasing, reducing, you are seeing everything. So just like you seeing the heart of what is going on, okay? So basically, that is that for the role. So safety. Safety is also very, very important. Like I mentioned, safety, operations, and environmental factors are things to actually consider during operations. Now, the key consideration here is your hydrocarbon containment, right? The key function of the safety personnel, or let's go further to process safety personnel now, is to contain any leakage. Okay, leakage from the flanges, leakage from the vessels and all the rest, from drain lines. You have to contain everything because those leakage are what cause accidents. Okay, so you have to contain all of them. Now, fire and gas detections. Okay, so designing fire and gas systems and also troubleshooting and then checking them at the role of process safety personnel. We have the emergency shutdown systems. Okay, the ESDs. We have produced water discharge limits. So these are things the safety officer have to look after, okay? Before waters are discharged, before the water is discharged into the open sea, they have to look at the limit before it can be discharged because of regulations, all right? The chemical handling and storage. So these aspects strongly influence offshore process design and operating philosophy. So we are at almost 2 hours now. All right, so I think we've gotten to the end of our training. Now, we need to take these questions down because you are going to be responding to these questions, and then you send it to me via WhatsApp using either Microsoft Word or PowerPoint. Okay, so the first question here is for you to define a fixed offshore platform and explain how it is structurally supported on the seabed. Okay, I've talked about this. You have to list out the major types of offshore production and states weather and states the water depth range where each is most suitable. Explain the difference between jacket platform and GBS. Describe functions of piles in a jacket platform. I stated it that the piles are what you use to anchor the mooring lines to the seabed. So describe the functions of this. And then next is explain 5 types of floating production systems used in offshore oil and gas. 5 types. Explain it. Then the main difference between an FPSO and FPU. FPU is floating production units. Okay, so explain the key difference between them, and then why are shuttle tankers commonly used together with FPSO? Why are they used with FPSO? Why not with a fixed platform? Why with FPSO? So explain that. Tell me why, and then list and briefly explain 3 common types of offshore petroleum license. I just mentioned them now. So list and explain them. Then what is the difference between an exploration license and a production license? Exploration license and production license. Okay. So I believe I've done justice to all these questions. So ensure to answer all of them because this is part of your assessment. Okay, so finally we are done with today's training. My name remains Ipe Gunati, and I want to thank you for your patience. Thank you for your understanding. Thank you for the questions, and thank you for the interaction. So let's continue with the interactions. Any questions from our audience?
Okay. Hello. Hello. Good afternoon.
Hello. Yeah. One after the other.
Good afternoon.
Please. Afternoon, sir.
Hello. Good afternoon.
Yeah. Yes, I can hear you. Good afternoon, sir.
Yeah, this is EB Akpabio from Angola.
Akpabio. Okay.
Yes. Please, I'm using phone here because I'm somewhere. Please, I would like you to type the question and send it to us. How can I have the questions? Because
you know what? I will send this slide to the group. Okay.
I've dropped a number. Check the message section. I've dropped a number. That's the number that you use and at me.
No, I said I will send this slide inside the group, our WhatsApp group.
Okay.
I will send it there. So when it's yes, you can just open it, then scroll down to the questions and then answer it. And also, after that you can see watch these questions because watch this video because on YouTube I'm going to add some quiz on YouTube. That is also part of your assessment. So when I post the video on YouTube, watch it and then also go and attempt the questions there too. Hope you understand.
Okay. Yes. Thank you.
Thank you very much. Hope it's not going to inconvenience anybody because it's just part of the learning process, okay?
Hello, sir.
Yes, sir.
I want to ask, are we answering all the questions or we're answering first section or we're just answering all? Please.
Sorry, I didn't get that.
The questions you listed out, are we answering all? Some of us are where we cannot use system, we use phone. So can we just answer the questions, type and send to you on your WhatsApp without using phone, without using system to go through MS Word and the rest?
What I wanted to do is I wanted to create a folder. So every day I will, we are so many in this group, okay? So I can't be looking at typed messages on WhatsApp. I prefer just download the PDF or MS Word and then save it in a particular folder. So let's say day 1, I will put all the answers for day 1 in day 1 folder, and then for day 2, just like that. But if you type it for me, it means I have to be the one to copy and paste on Microsoft Word and then save it. I don't know if it is okay for you to just try your best and ensure you send it to me as a PDF format.
Okay. Okay. Thank you, sir.
Thank you, sir.
Hello, sir.
Yeah, well done, sir.
Okay, so I'm from Ivory Coast. So I want to know about the question. Then I finish. I can send it to you after. Already now.
Sorry, ask again. My volume is a bit low, so I can't hear you clearly.
Okay, I said about the question. Then you finish to answer. Is it possible to send it to you now or after?
Anytime you're done. But we have another class next. We have another class next tomorrow.
Okay, white.
Yeah, so if you can send it today, tomorrow, it's fine.
Okay.
All right, sir.
Thank you.
Thank you very much.
I also have a
Hello,
question.
sir.
Yeah,
Hello.
well done, sir.
Good afternoon.
Hello.
Good afternoon, sir.
Thank you for your wonderful presentation. We appreciate you. So, though I came in late, I forgot. So, number one, how do we get these questions? Sorry, the whole video rather, for those that entered late. Is it only through YouTube?
Okay, yes. I will post the video on YouTube. Then I will send it to the group. Then also the material I use for this training, I will also send it in the group.
Thank you very much, sir.
You're welcome, sir.
Okay, you said the
Hello,
next class will be tomorrow or next tomorrow?
I'm from Angola.
Yes, we have class next tomorrow. Yes.
Antonio.
Oh, that's on Monday.
Yeah, I'm
yes, on
Antonio.
Monday.
I'm
Yes,
from
on Monday.
Angola.
Same time on Monday by 1 p.m.
Okay, can we look at the timing
Hello?
very well on Monday, because Mondays are usually very busy for almost everyone, especially in Nigeria. I don't know if it will be possible.
Sorry, you said you want
Maybe
to look at
just
what?
to review. I said, can we actually review the timing on Monday? Maybe Monday, normally Monday is a very busy day. So I'm just pleading that if we can review the timing when people will be less busy.
Okay, the problem with changing the time is going to affect other people. Now, because you are in Nigeria and your time is okay with you, if I change it, other people might not be okay with it. That is the problem now. So maybe on Monday, maybe we can do a vote. We can we'll drop a vote in the group. Then we'll vote. If we can shift it maybe 1 hour ahead or 2 hours ahead, if everybody accepts, then we can do that. For me, I don't have any problem. I'm just trying to make everybody have that time to be present in the class.
Okay.
I think in addition, since the classes or the lecture will be recorded, we can always go back to it.
Yes, exactly. So even if you miss the class, you can always go back and watch it.
Yeah. So that works. Thank you, sir.
Okay, sir. Mr. Harrison Amoa, you've been raising your hand, please.
Okay, so my question is the questions that we have to answer. Where we answer, like the mode of submission, should we answer it in an MS Word, or it's made in such a way that a Google response, you answer and it gets to you, or how do we answer the questions, and where do we submit it? Thank you.
No, it's simple. It's MS Word. MS Word. Just give me the question and the answer. Just explain your answers very well, all of them in one document, and then you send it to me.
She send it to you on WhatsApp?
Yes, you can send it to me on WhatsApp.
All right, thank you very much.
You're welcome, sir. Okay, so we have just 1 minute left, so we can end the class.
Sir, it was a wonderful session. Thanks for your time. Venkatesh from India. So you are sending the document in WhatsApp, question document, and we have to submit answer also with the same WhatsApp.
Hello, sir. Sorry, sir. Your voice. Just try to. I can't hear you clearly. Just increase your volume.
Now it's much better. Now how it is? Is it okay now?
Yeah, a bit.
Yes, sir. What I'm asking is, you are going to send the questions in WhatsApp, and we have to submit our answers also in the WhatsApp only, in the same group?
Yes, the same group.
All right, sir. Thank you.
Welcome, sir. All right. So, thank you very much for today. We are going to meet on Monday again. So you guys will prepare. Before Monday, I think by tomorrow I will send a link so that you can see also the breakdown of what you're going to learn, the topics. Okay. So by tomorrow I'll do that so that I can prepare on Monday. Then we'll continue. All right.
Sorry, before we sign off, sir.
Right. Okay.
Somebody is suggesting we do it on Google so that you can see it in real time instead of downloading over 300 documents. Somebody suggested that in the comments, that if we can put it on Google Doc, so you just see it in real time.
No, there's a reason I'm putting it on YouTube. Like I said, there are questions on YouTube that you are going to answer. There are questions you are going to answer on YouTube.
No.
There are
I'm
questions.
saying the mode of submission. I meant the mode of submission of the assignment instead of sending it on doc.
Okay. You want to
Somebody is
send it?
suggesting that we send it on a Google Doc so you see it in real time. You don't have to download question and answer like our submitted assignment.
No. I prefer like that. I prefer the downloaded one because I will put it in a folder.
Okay. All right.
Yeah, I prefer that one. Thank you very much. All right, so I'm going to stop the class for now. We'll see you guys later on Monday. Thank you very much.
Thank you.
Thank you, sir.
Thank you, sir. God bless you.
You're welcome. You're welcome, ma'am.
Thank you.
Thank you, sir. Thank
God
you.
bless you, sir.
All right.
Thank you very much.
Thank you, sir.
Thank you, sir.
Have a lovely day.
Thank you.
Thank you very much.
All right. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
All right. Thank you very much.
Thank you. Thank you, sir.
Thank you, sir.
We are very grateful.
See you on Monday.
Thank
All
you,
right.
sir.
See you on Monday.
See you Monday.
Thank you very much, sir.
Enjoy the rest of the weekend, sir.
All right. Thank you.
Thank you very much, sir.
Thank you so
Welcome.
much. Thank you very
All
much,
right.
sir.